Hi, welcome to AB Video 5.5 Part 1, Introduction to Derivatives and Integrals Involving Other Exponential Functions. Okay, so bases other than e. So let's talk about exponential functions. So now instead of y equals e to the x, what if it's a to the x, where a is some constant, 2 to the x, a half to the x, etc. Okay? First of all, that base will never be 0, that base will never be 1, and that base will never be negative, because if you had negative 2 to the power of a half, you'd have the square root of a negative, which is an imaginary number. Okay, so the graphs look pretty well the same as y equals e to the x. The only thing is e is bigger than 1. If it's a half or 2/3 or 4/5, then what happens is when you when you have a fractional base that's less than 1, between 0 and 1, instead of the graph rising and going through 0, 1, it's going to fall. Like you could actually think, let's say this was y equals 3 to the x. So 3 to the 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9, 3 to the negative 1 is 1/3. Whereas over here, if you have a half to the 0 is 1, a half to the 1 is a half squared is a quarter, but a half to the negative 1 is 2, a half to the etc. Okay? So just as a recap, remember we learned in 5.4 that the derivative of e to the x was e to the x. So this is a very similar formula. The derivative of a to the x is a to the x, just like the derivative of e to the x is e to the x times ln a. Now, if you did replace the a by e, it would be e to the x times ln e, and of course ln e is just 1. So the derivative of 3 to the x is 3 to the x times ln 3. So formula is derivative with respect to x of a to the u is equal to a to the u times ln a. And then, of course, times the chain rule. So, for example, if you have the derivative of 5 to the x squared plus 1, it's itself, which is 5 to the x squared plus 1, times ln 5, and then, of course, the chain rule, the derivative of x squared plus 1 is 2x. You could rewrite this as 2 ln 5, which is kind of your coefficient, x over here, and then 5, okay, to the power. Okay, if the derivative of a to the x is a to the x times ln a, then it makes sense that the antiderivative of a to the x dx is a to the x divided by ln a. So, for example, the integral of 2 to the x dx is 2 to the x divided by ln 2. So your formula, integral a to the u du is a to the u over ln a. Again, you're going to let u equal the exponent. So if you have the integral of a half to the 3x, you'll let u equal 3x. Your duh is 3 dx. I have the dx. I don't have the 3, but I can introduce and counteract. I have 1/3 integral of 1/2 e to the u du. Well, the integral of e to the u of 1/2 to the u is, or a to the u is a to the u du. So that's going to give me my 1/3 on the outside. When I integrate a half to the u du, I'm going to get a half to the u divided by ln of a half plus c. Now you would have to replace the u by 3x. This, of course, is ln1 minus ln2. ln1 is 0. So there's many different ways to rewrite this same exact answer. And I had blah, 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 blah. They're just all different ways to write the same answer. Okay, now we know that from 5.1 that the derivative of ln x is 1 over x dx. But what happens if we want to take the derivative of something uglier? Let me just pause for a second. Okay, so in the book they have this formula, which personally I have never memorized. And the reason I've never memorized it is because you should have learned the change of base formula in both Algebra 2 and in pre-calc. The change of base formula says if you have a logarithm in base A and you would like to change it into base C, then log base A of B is log base C of B over log base C of A. Basically, what's on top stays on the top, what's on the bottom stays on the bottom. So for example, log base 3 of 7, if you wanted to change it to base 10, would be log base 10 of 7 over log base 10 of 3. If you wanted to change it to ln, it would be ln of b over ln of a, etc., etc., etc. Okay? So rather than memorizing that weird thing, when I see that they're asking for the derivative of log base 3 of x, right away I just change it to base e. It's very simple to do. It's ln of the top number, which is x, divided by ln of the bottom number, which is 3. So you have ln of x over ln of 3. Now keep in mind ln of 3 is a constant, so I can pull that fraction on the outside. It's 1 over ln 3 I can pull on the outside. And then I have 1 over 3 times d dx of ln x, which is 1 over ln 3 times 1 over x, and that'll give me 1 over x ln 3. The only thing is in the back of the book, chances are, because the question was given with log base 3, they're going to want the answer with log base 3. Well, then you just change it back. So what happens is, I'll show you here on the side, ln 3, if I want to change it, which is log base e of 3, if I want to change it to back to log base 3, is log base 3 of the top, which is 3 over log base 3 of the bottom, which is e. Well, of course, log base 3 of 3 is just 1. So we end up, I can replace ln 3 by 1 over log base 3 of e, and then I multiply by the reciprocal, and there's my answer. Okay, so a little bit more about exponential graphs. Y equals 3 to the x minus 1. That's going to take the graph of y equals 3 to the x, which would rise because 3 is bigger than 1. But it's going to move it to the right one. So that anchor point 0, 0 is now at 1, 1. So it'll rise very slowly until it gets to 1, 1 and then rise quickly. Y equals 3 to the negative absolute value of x. Well, what happens is if you look at the graph of without the absolute value of y equals 3 to the negative x, which, by the way, there's two ways to look at this. One, look at the graph of y equals 3 to the x and flip it over the y-axis. Another way to look at it is 3 to the negative x is 1 over 3 to the x, which is 1/3 to the x. And because the base is between 0 and 1, it decreases rather than increases. Either way, this whole graph is the whole green graph here is the graph of y equals 3 to the negative x. But what we're doing here is putting an absolute value around the x. So what we're saying is whatever happens when x is positive is going to happen when x is negative. So when x is positive, we get this little red portion here. So we're going to just flip that over the y-axis. Y equals 3 to the negative x, you're going to flip it over the y-axis. So y equals 3 to the x would look like this. Flip it over the y-axis, it looks like that. Y equals negative 4 to the x. The negative, just like y equals negative x squared, we'll flip it over the x-axis. Here you have all kinds of things going on. 2/3 is between 0 and 1, so it would fall, and then you're going to move it to the left 1 and down 3. So you kind of start over here with your y equals 2/3 to the x. And then I'm taking that anchor point 0, 1. I'm going left 1 and down 3, which will put us at negative 1, negative 2. And of course, since everything's moving down 3, and since this has a horizontal asymptote of y equals 0, the horizontal asymptote will also move down. And